Yeah, well, I know that nobody wants it to snow here, so, because they wouldn't want to miss any school. So thanks for speaking to us. Can you tell us a little bit about your background, please?
Sure. I started out playing video games for a living back in the 90s. One of the few people that began doing that in Boulder, Colorado. And I did that for a few years, and then I transitioned over to proprietary software training. So I traveled around the country and sometimes outside the country, training people in really boring and dry software. And I did that for the better part of 20 years. And then, not too long ago, less than 5 years ago, I got into this and looked at the theory and thought it was terrible. Tried to shoot it down, and here we are. 5 years later, it's turned into a blossoming cottage industry.
That's certainly true. So, the readings you gave me, I put on the syllabus. In my experience, most people usually do the readings, so they're already familiar with the basic arguments. But
Cool.
could you kind of run down the ideas for us, please?
The ideas here, I even got props for you guys.
Okay, thank you.
Not often I bring out the props. Usually I save those for conferences and stuff. So the basic idea is that you think you're living on this little tiny rock that's flying through space in an impossible universe in multiple directions and varying speeds. And our community thinks we're living in this. Just basically an enclosed snow globe type system with walls and a floor and a ceiling, and there is no space. What you see up in the sky are just lights, pretty lights, no different than you would see in a planetarium. If I know it kind of dates me, I don't know if you guys even have a planetarium out there. But that's what we think. And if you want the zoomed in view, you've probably seen this before, which is, you're living in basically a giant saltwater lake inside that place, and there's islands inside, which we know are continents. And the whole thing is surrounded by the continent of Antarctica, which looks nothing like it does in the normal maps. That's the gist of it.
And what, I'm having a little trouble because this is such an unusual idea. What led you to this belief? Like, what evidence is there for this?
Gotcha. What led me to it was the same thing that leads just about everybody to it, which was I tried to shoot it down. I hated Flat Earth. In fact, there are mornings I still hate Flat Earth when I have to get up at 2 a.m. to do some international thing. What got me into it was reasonable doubt. Meaning, and if you read the book, or read even part of the book, or watched any of the videos, can I prove to you the Earth is flat right now? No, I cannot. Not with 100% accuracy. Can I create so much reasonable doubt in the globe that the only place you have left to turn is some sort of flat Earth model, some ethereal version of this, which is why there's so many different versions of this? Yeah, I can. I can do that all day long. And you're saying, if you know anything about the legal field, well, reasonable doubt isn't enough. It's like, oh yeah, it is. In court, reasonable doubt can win any day of the week. And that's how we all got into it. See? There are more holes in the globe model than there are in the flat Earth model. In fact, real quick for you, just because easier is better, we've created a model, or we've described a model that is now easier to explain than the globe. And what I mean by that is, even though these two objects seem to be of the same size, this cannot exist on its own. This needs a solar system around that, and a galaxy around that, and a universe around that. And it uses a huge amount of geometry, trigonometry, and calculus, and quantum mechanics, and all that stuff. Whereas this needs nothing. It barely even needs algebra. That's all it is. And you're thinking, well, just because it's easier doesn't mean it's right. It's like, no, not necessarily, but easier always resonates with the general public. To use a quote from The Art of War, people are like water. They always take the path of least resistance. Why did we switch real quick from talking on phones for decades and decades to texting? I mean, has anyone in the classroom even made a phone call where you've actually talked to a person in the last week? Yeah. Maybe not. Why? Because it's emotionally easier to text. But that's a whole other thing.
Again, you'll excuse my
No.
I'm usually quicker on my feet, but this is taking me a little bit of time to process. So when there's a satellite
Yeah.
that goes up, doesn't the satellite capture the sphere and the rotation of a sphere?
Or it's traveling above us in a circular pattern, no different than a mobile above a child's crib. And by the way, I'm not saying that there aren't satellites. I've probably said that in the book several times. You want to look up what the real thing behind satellites, look up the high altitude balloon program from NASA. They are the world's largest consumer of helium, always have been since the beginning. They can launch payloads with balloons, either helium or hydrogen, upwards of 4 tons, which is 8,000 pounds. If they can do that all day long, they do hundreds of these every week. So why would you put anything on the top of a rocket? You wouldn't. What I'm saying is the satellites are very, very low by comparison. As far as geosynchronous orbit satellites, doubt it. Doubt it, highly.
So okay, so I'm just trying to work through this for myself. So the satellites
Yeah.
are there, and you mentioned in the reading, I didn't get the book, but I got the reading. You mentioned it, but the satellites don't capture what we think it captures. Is that the idea?
No. The images, any images you see from decent altitudes are most likely from spy planes. You know, military spy planes cap out at about 20 miles, and that's high enough to give any sort of satellite type imagery. In fact, you could map just about everything with high altitude spy planes. When it comes to the bandwidth, can satellites generate some bandwidth? Sure. But anyone in the communications field will tell you, and I've talked to them, that 95% of the bandwidth, including what you've got in your cell phones and what we're talking through right now, is fiber optics and compensated with cell towers. Satellites are used for barely anything nowadays.
Do you think that it's, and Neil deGrasse Tyson has come out and made...
How dare you bring up that name, sir?
Okay.
How dare you?
Well, do you think it's that people are mistaken, or do you think it's that people are actually deceptive?
Which group are we talking about here? Just anybody in the people in science?
Astrophysicists, people with domain-specific expertise like astrophysicists.
Oh no, they're just mistaken. There was a great quote by Nikola Tesla, who, one of the most underrated scientists in history, where he said that science has a notorious habit of just building on top of each other in tiers without actually examining the core foundation. And so he goes, when you get to a certain tier, because nobody's double checking the work below it, the work becomes meaningless. So it's not that astrophysicists aren't smart guys. I've been asked this many times. Are you more intelligent than Stephen Hawking or Albert Einstein? It's like, no, I don't have to be. Because if the foundation that they based on their work on was wrong, then their work is wrong. Not knocking anyone that's into physics and astrophysics or the physical sciences, but if the foundation, the premise that all the elevated computations are based on is mistaken, well, they're wrong, but not because of an intelligence issue. How's that?
Okay, how could we, so in this class, I don't know if I sent you the syllabus or not, but one of the things we do is science and pseudoscience, and we look at claims and we try to apply the scientific method to those claims, and I try to do the best that I can to teach people, this is a scientific test, this is what it means, and scientific method, etc.
Sure.
What scientific tests could we perform to show that the Earth was flat?
Sure. I'll give you the example, and I don't know if it was in the reading or not. There was a German television team that asked me that very question for astrophysicists out of Georgetown University. And they said, come up with 5 scientific things that we can do, that we can throw at this guy, and then we will take your recording and we'll go back and forth, and we'll just shuffle tapes back and forth, because you guys are never going to talk to each other, because no offense, most scientists, by the time you get up to your master's and your PhD, are pretty dry, pretty monosyllable type guys. Most of them, not every in this room, I'm sure, perfectly great. But other people, not so much. So the 5 things we threw at him was, well, me, that I threw up was this. First thing was long distance photography. That is by far and away the easiest thing to test. And it's I didn't even come up with it. Somebody in the community came up with it. People just started running down to the beach with high definition cameras. Most notably the Nikon P900 and now the P1000, and I think the 950 is coming out soon, with massive zoom. And so here's the question is, if you're looking off into the distance, don't forget about left to right. If you're looking forward to back, you're looking off into the distance, eventually the curvature of the Earth is going to hide objects. And the curvature formula in mainstream science says it's 8 inches per mile squared, which means it's every mile per mile. So like 3 miles would be 3 times 3, which is 9, times 8 is 72. 10 miles would be 10 times 10 is 100, times 8 is 800 inches. And it gets worse and worse and worse because it's supposedly going to go vertical. So eventually, whatever object you're looking out off into the distance, you got to use water because it's the only thing that remains level. And you could use the salt flats if you really want it. You might run into some heat issues, but it doesn't really matter. Water's easy to get to. That boat, that lighthouse, that island should be gone. It should be on the other side of the hill. It should be behind the curve. Should never ever come back. And 10 years ago, I would have been right there with you. But now, when you crank up the zoom on those cameras, now those objects come back into frame. And they come back perfectly. In fact, the only question is atmospheric conditions, because we're looking through kind of a soup. And that was the first thing that everybody jumped on, which in fact, I was, in the models that I liked the Orlando Ferguson model, which was kind of shaped like a roulette table. But people says, oh, you can't just use a roulette table. I go, why not? Because they said all the numbers in a roulette table add up to 666. They're absolutely right. It's like, ah, crap, well, I'm not going to use that. So they said, no, it's tabletop flat. They could never ever find the curvature.
Okay.
So that was my.
Let's linger on that for a second. So
Yeah.
I have been taught, and I've experienced this myself, that if you're on a beach and it's a let's assume that their atmospheric conditions are, it's a nice day. In other words, it's a nice day, and you look out into the water,
Yep.
the last thing you see as a big ship sails away from you, away from the coast, is the tip of the mast. In other words, if the world was flat, the whole thing would just disappear. But because the Earth is curved, the last thing you see is the top, is the very top of the mast.
Right.
How do we explain that?
Atmospheric lensing. I didn't even know that was a thing. We had to look that up. That's a mainstream science thing. That's not us. So what you're looking through what we're talking in right now, what you're breathing is only about 99% transparent.
Breathing.
You're breathing in.
Oh, breathing. I thought you said grieving. I'm like, wow.
Oh, sorry, breathing.
Breathing
Sorry.
doesn't use me that very much. Yeah.
What the air that you're sucking in your lungs right now is only about 99% transparent. In fact, it's barely even oxygen. It's let's say 4 parts nitrogen to 1 part oxygen. So it has a thickness to it, and it's no different than water when when divers get down to a certain depth. You can't see the sun, 12 o'clock behind you and above you because the sun cannot penetrate the water. The air that you're breathing in right now, no different than that. It's just thinner. So when you go out to a certain distance, the air turns into a big lens. And you don't need a mast ship to show this as well. You can also show this with tankers and cargo ships and stuff like that. And you'll see this weird blurring effect to where the boat, will be chewed up. But it's not that you're just seeing the top of the mast, it's that the atmospheric lensing just fuzzing out the bottom of the boat.
Fascinating.
So.
All right, cool. So
By the way, it doesn't happen all the time. The atmospheric, it also depends on light and heat, humidity, and all the other things. So I know you're limited time, so go ahead, go.
No, I'm trying to be so you said, I asked you a question, you gave one, I asked for a clarification of a counterexample, and here's, if it's okay with you, could you give us the other 4, and then I'd like to open it up to student questions? But I'd like them to hear the other 4.
The other 4 things, the second was gravity versus the vacuum of space. So is there a second floor to your building right now? Is there a floor above you?
Yes.
Perfect. Okay, let's say you took the second floor of that building and you turned it into a vacuum chamber, and you put a hole in the ceiling, you put a cork in it, and you pop that cork. What's going to happen? It's going to equalize. The pressure is going to go from your room to that upper room. It's going to be instant. It's going to be violent. You're probably going to pass out. Some of you might even die. That's probably not even something you want to think about right now. But if you want to see a great example of that, look up on YouTube. The Germans love doing this. I don't know why. Vacuum versus steel rail car. Not aluminum rail car, steel rail car. They apply a vacuum field to a steel rail car on the tracks, and it crushes instantly. It's in a fraction of a second. All those movies you see about space, where it's like you get a hole in the spaceship, it's like, oh, we only got 2 minutes of air left, somebody get the duct tape. Oh, no. It is instant. That is, anytime anyone does that in the movies, it is strictly for the plot. It's for the drama. So the question is like, okay, Mark, what are you talking about? So my question is, if the air upstairs in you equalized instantly, then why doesn't the vacuum of space suck the atmosphere off this world right now, instantly? And you're going to say, well, because of gravity. I go, oh, no. Why didn't the gravity in your room right here keep the gravity in your room instead of rushing upstairs? Remember, that's just a small vacuum chamber. The vacuum chamber of space supposedly is much, much bigger. Why doesn't that happen? No one can ever explain it. In fact, find me a scientist that tells me exactly where the bleeding edge of space is. Where does our atmosphere end and space begin? Third one, moon eclipse shadow, which is this. You guys were, in fact, I went down to Oregon. Was it Salem, Oregon, for the big eclipse a couple of years ago?
Yeah, I was there too.
Yeah, I was there in a little park. It was wonderful. We shot part of the documentary there. And so the eclipse shadow, the moon is supposedly 2,000 miles wide, but the eclipse shadow, the blackout zone is only 70 miles wide. That's like a 97% decrease. Why does it get so small? Why is the blackout zone so very, very tiny on such a massive object? And scientists say, well, it's condensing the shadow down to this pinpoint. It's like a magnifying lens, only with reverse. And I go, okay, fine. We don't see that in real life ever. First off, you walk by a building and the sun hits you, your shadow never ever gets smaller, never shrinks down to the size of an action figure. But even if that were true, even if you could convince me that it happens, why doesn't it happen reverse for the sun? So when the sun gets in front of the Earth, the Earth gets in front of the sun, why don't we see a blackout zone on the moon that's 4 times larger, say 250 miles wide? The moon should turn into a big eyeball sometimes. Never ever does. And it works way better for our model than anybody else because we say the moon and the sun are only about that wide. 50 to 70 miles, not a stretch for us at all. Fourth, moon temperature. I didn't even know this was a thing until I was into this a year. Somebody called me up and they said, oh yeah, by the way, the moon's cold. And I go, yeah, we all know it's colder at night. What the hell are you talking about? They say, no, it generates a cold light. I go, what do you mean? They go, well, if it's 80 degrees in the sun and 70 degrees in the shade, we all know that an object will block some of the sun's rays. It's cooler in the shade. But in the moonlight, it's actually the opposite. So if it's 50 degrees in the moonlight, it's 60 degrees plus in the moon shade. It's actually warmer in the moon shade. That's impossible because, as you know, the moon is reflecting the sun's rays. It's reflecting some of it. That's how the moon glows, right? It reflects some of the sun. In fact, you can test this with a point-and-click $20 thermometer you can test at the hardware store. I've tested it myself. We've done it with copper strips. In fact, not only does it get colder, but if you take a magnifying glass to moonlight, it even gets colder. So like magnifying glass of sunlight, you can burn paper and things like that, but moonlight can actually get colder. It's technology we have now. It's called a cool laser. Universities, in fact, your university may even have it if you have a science department like that, where you can change the frequency of laser light and actually make things slightly colder. Not, Mr. Freeze, Batman type stuff, but still colder. Last one, number 5, is the Van Allen radiation belt trap question, which I came up with myself, which is, are the Van Allen radiation belts deadly? Yes or no? It's a simple question. If yes, because that's what they were announced to be super deadly in 1959, how did the Americans make multiple round trips during the late 60s and 70s, at least 6, maybe even 7, with no shielding whatsoever? The only things that can stop radiation are gold, lead, and a whole bunch of water. And the Americans went round trips with just aluminum and plastic as shielding, and nobody died, nobody got radiation poisoning, nobody even got cancer. There's still 5 of these guys walking around today. Say, okay, well, maybe it's not detonate. Okay, go to the NASA.gov website and look up the video Orion Trial by Fire, which says that they will not test manned capsules for any sort of Mars program until they can solve the radiation problem. What are you talking about? You solved the problem back in the 60s. You solved it perfectly. No one's ever had a problem with radiation ever, not only inside the capsule, but the suit. Long story short, I threw those 5 questions out there. The Germans recorded it, sent it off to Georgetown. The guy folded like a card table instantly, and that was it. They went home angry, and the segment never ran. I've still got the interview on my channel, the audio part of it, but it didn't surprise me because most scientists are narrowed down to a specific field, and that was kind of a shotgun pattern of questions, and I knew he couldn't answer all of them, but at the very least, I think he should have addressed some, and he didn't.
Yeah,
So there you go.
So I know everybody's itching for questions. I am also itching for questions. So let's just, again, linger on that last one. So
Yeah.
when an astronaut, when they build a rocket, and the astronaut, they get in the rocket, and they go to the moon?
Yeah.
Or do they just think they're going to the moon?
No, it's worse. To quote Mission Impossible, it's worse than you think. What I'm saying is that NASA, 99% of the people in NASA don't know anything. They build the rockets, they polish the fuel systems, they do all sorts of fun stuff. They don't know. No astronaut's ever going to get on the top of a pile of liquid explosives, ever. Which is why I love the movie Capricorn 1 so much, because it showed how easy it would be to fake it. You just say the astronauts are in the capsule, you take them to an Air Force base, you keep them there for a few days, you put them in another capsule, you drop them in the water, or now in the desert, because they don't even land in the water anymore, and they can say whatever they want. Don't forget, and again, I'm not trying to say that people are evil, but for God and country, we're talking about soldiers here. All astronauts are Air Force officers, and in fact, not even low ranking. Most of them are colonels or higher. One of them, I think, was a lieutenant general. So, if you're asked, you've already signed the waivers. Like, look, we say things we shouldn't for God and country all the time. So no astronaut's ever been anywhere.
Okay, so just so that we can drill down, so I'm clear on this, so I want to make sure I understand this. So they get in a rocket,
Yep.
and somebody moves the rocket to make them think that they're...
No. They're put in a truck, and they're told they're put in a rocket, but I doubt they ever get to the top of the rocket at all. The rocket goes up, splashes down in the ocean somewhere. The astronauts sit comfortably in an Air Force base.
Okay, so the rocket does go up.
Oh yeah. No, the rockets absolutely are real. NASA builds rockets, and the rockets do go up. Sure.
Okay, so I'm just trying to understand. So there's a rocket,
Yeah.
and let's say, like Buzz Aldrin or someone, does he get in the rocket?
Nah, why? No point. I mean, I suppose you could if you really wanted to push the theater option, but you don't have to have him climb up to the top of that thing.
Okay.
With a rocket. You could just show footage of him going into a capsule.
Sure. So in other words, they're in on it.
Yeah, oh God, yes. Yeah, but not in the sense that I don't think anybody other than Apollo were told exactly why. The Apollo astronauts, I think, were told. If you watch the movie The Right Stuff from the 80s, I think that really was a great hero program. It was the best of the best, and I think these guys were supposed to do what they were supposed to do. And then they told them at the last minute, oh yeah, you're not going to be doing this, and here's why.